Hello everyone, what I have here is called a monochrome LCD display. I'm sure you have seen these kinds of displays in all sorts of electronic devices such as printers, fax machines, washing machines, ovens, etc. These are also used with microcontroller and microprocessor based systems. In today's video, I'm going to show you how to control such a LCD. Before we get started, let me describe the pinout of this LCD. The first pin we see here is the VSS, which connects to ground. The second pin is the VDD, which connects to plus 5 volt, and the third pin is V0, which is for contrast adjustment. And following that we have the RS or register select pin, which is used to indicate that the given data is a character or an instruction. And following that we have the RW or read write pin, which is tied to logic 1 for reading and logic 0 for writing. And following that we have the E or enable pin, and I'll talk about it a minute later. And following that we have the D0 through D7 8 data pins, and following them we have the anode and cathode pin. Now that we are familiar with the pinout of the LCD, to demonstrate its working I have designed a circuit. And this is the circuit that I have designed. As you can see that this box here represents the LCD, and these 8 switches represents the data bits, and on the left side we have this latch. Now starting from the very last pin we have the cathode of the backlight, which is connected to ground, and next to that we have the anode of the backlight, which is connected to plus 5 volts through its current limiting resistor. And following that we have the 8 data bit pins. As you can see that these data bit pins are being pulled to logic level 1 through this 4.7 kilo ohm resistors, and they are also connected to this switch, which is connected to ground, which means when you flip the switch a logic 0 is written on that data bit pin. And following the data pins we have the enable pin, which is connected to the output of this latch, and next to that we have the read write pin, which is connected to ground, which means we are writing to this LCD. And next to that we have the register select pin. The register select pin is either connected to plus 5 volt or connected to ground through this switch. And next to that we have the V0 pin, which is for the contrast adjustment. As you can see that this pin is connected to the wiper of this potentiometer. And next to that we have the VDD, which is connected to plus 5 volts, and the very last pin VSS, which is connected to ground. Now here is the actual circuit on a breadboard. As you can see this is the LCD module, and next to the LCD module we have these 8 dip switches. Now the one side of these dip switches is connected to ground, and the other side of these dip switches is connected to 8 data bit pins. Now these data bit pins are currently pulled to logic level 1 through these pull-up resistors. And right here we have the latch circuit. The reason I have implemented a latch is that mechanical switches have the bouncing problems, which means even if I push the button once, owing to the bouncing phenomenon, the enable signal is interpreted several times, which results in multiple commands. And on the left side we have the contrast adjustment potentiometer, and on the right side of the latch we have these two switches. One of these switch is connected to the register select pin, and the other switch is connected to the input of this latch. Let's power up the circuit and observe what happens. Nothing. When we first initialize the LCD, nothing happens. Just the backlight turns on. In order to initialize the LCD, we have to issue two important commands. Now, here are the commands and their opcodes. One of them is the display and cursor on off, which turns on the display and places a blinking cursor on the top left corner of the LCD. We issue these commands through these 8 dip switches. Now the register select pin is connected to ground, which means the given command is an instruction, not a character. Let's set the dip switches in the desired manner and observe what happens. Looking at the opcode, now the enable pin comes into the play. The LCD reads or writes data by setting the enable pin to logic 0. Let's set the enable pin to logic 0 and observe what happens. Adjusting the contrast, as you can see this puts a blinking cursor on the top left corner of the LCD. Now the second command that we have to issue is the function set command. The function set command sets the number of lines used, the data bit length, and the pixel size. Looking at the opcode, pressing the enable pin, adjusting the contrast. See, LCD has been initialized in 2-line mode and the pixel size is 5 by 8 pixels and the set data bit length is 8 bits, so the LCD is set to accept 8-bit data. Now that we have initialized the LCD, let's try writing a character on it. Now you may be wondering, what are the commands for the characters? This is a fairly standard device, so it uses internationally accepted ASCII code. And here is a chart that I have made using the ASCII code table. It lists all the commands for all the characters that we will be using. Now let's try writing hello world on it. First, the command for H, 0100 1000 0100 1000. Now pressing the enable key. Now the command for small e, now for L, pressing the enable key. L is 2 times, so again pressing the enable key. Now for O, now for space, now for capital W, for O, now for R, for L, now for D, and the exclamation mark. There you go. We have successfully write hello world on this LCD screen. Now, after watching this video, I hope that it may have developed a basic idea of how these LCDs work and how a microcontroller / microprocessor uses them to display data. For example, the 8 data bits can be sent by a port on a microcontroller / microprocessor, and other control signals can be controlled by another port. In this video, I just covered how to write data on the display, but it can also be configured to read data from the display. Of course, there are many more features offered by these LCD displays, such as displaying custom characters, manipulating text left or right, scrolling right or left, and so on, but they are topic for another video. I hope you may have enjoyed this video. This is Web of Khatri. Thank you for watching this video.